Here's a nice example of using inductive and deductive reasoning to prove a conjecture. So in this case, it says our conjecture is that the sum of four consecutive integers is equal to the sum of the first and last integers multiplied by 2. So to prove this deductively, we're just going to use examples. So I'm going to start with 1 plus 2 plus 3 plus 4. According to my conjecture, it should equal 2 times 1 plus 4. I simplify both sides. This side I get, this side is equal to 10. And 10, in fact, is equal to 2 times 1 plus 4, or 2 times 5. So that's correct. Choosing a second example, I could use 2 plus 3 plus 4 plus 5 equal to 2 times 2 plus 5. Remember, it's the first and the last. The left-hand side is equal to 14. The right-hand side is equal to 2 times 7, which again, we know is equal to 14. So that one's okay. And finally, we'll use 3 plus 4 plus 5 plus 6. Notice I'm using consecutive integers. So that should equal 2 times 3 plus 6. Following the same procedure, the left-hand side gives me 18, and that's 2 times 9, which we know is equal to 18. So inductively, everything looks fine. Now we want to prove it for the general case, or deductively. So in order to do that, we got to introduce variables. So my first integer is going to be n, second one, n plus 1, n plus 2, and finally n plus 3. Notice they're consecutive, one follows the other. That should equal 2 times the first we called n, plus the last, which we called n plus 3. Now, if I look at the first or the left-hand side here, if I combine like terms, I get 4n plus 6 on this side, and that should equal 2 times, if I combine what's inside the brackets, I get a 2n and plus 3. Now, if you're careful to use your distributive law on the right-hand side, 4n plus 6 on this side doesn't change, is equal to 2 times 2n is 4n, 2 times 3 is 6. So now you've proven the case both inductively and deductively.